so first of all, thanks everyone for attending despite the good weather. As Antonio said, our lab's name is Fundamental AI Lab, or Fun AI for short, so I'm hoping that you'll also have some indication of why we tend to abbreviate our lab this way. So first of all, just to fetch everyone, right, like what is self-supervised learning? I mean, everyone has probably by now heard about it. There's many kinds of definitions what it is. So I thought we might just start with like talking about it. So I would like to define self-supervised learning with this nice image, which actually isn't AI generated. Self-supervised learning, we have two things, right? Like we're trying to learn neural network models. And in this case, the forward momentum, so the model improving in some desirable way, is the dog just moving forward. How is the dog guided? Well, in this case, it's not guided by a human, but the leash is just given by the data itself. So just the normal data without any human annotations at all. And then why the dog or why the model is moving in a way that it does, that's the motivation, that's the pretext task. So that is something that involves a loss function, right? Like if you want to train a neural network, you need to have some cost function which is which has a derivative in order to update the weights. And we'll talk a bit about what kind of loss functions we get there. But the main thing is there's no human, right? And so what does this mean? You can scale your data sets massively. So if you look at the left-hand side, this tiny dot, that's roughly like ImageNet 1K size. If you move to weakly supervised data, like the ones people use for CLIP or stable diffusion and things like that, these are all text-image pairs. Of course, by now we have billions of them, 100 billions, but still 100 billion is tiny compared to the raw amount of data you have available on the web and in the world, right? Like think of all the self-driving cars driving around, recording terabytes of data every day. Same with satellites, surveillance cameras, everything. So the amount of unsupervised data you can use is sheer massive. But there's other benefits as well. So if you're trying to train a neural network for a particular application, and you're doing that in a supervised way, you might need to constantly relabel your data, right? Like in a domain where you have fashion changing, items changing, smartphones, cars, etc. You constantly need to relabel. Like here you can see the cars has changed a lot. And plus, you don't even know in the real world when you need to relabel, so your model might be secretly getting worse. Unless you're driving Lada cars, they stay remarkably constant for more than 20 years. Same design, very efficient. And for me, especially as a computer vision